So, next presentation is coming from Laurence Kirk. He's the founder of Xtropy. So he'll be talking about smart contracts on Ethereum. Can we have you on the stage, please? So you're welcome. How are you? Thank you. It's all yours. Thank you.
Thank you. Talk about smart contracts to explain to you how they work. I'm not going to talk for too long. I think it's more important that you get a chance to ask questions about them, see how you could apply them. So I'm just going to cover a few points. Now, when people talk about smart contracts, they usually start by saying, well, they're not smart and they're not contracts. And this really displays that there are some different perspectives that people have about smart contracts. And I think that's often due to the way that these were started, the history of smart contracts. So Nick Szabo, when he coined the phrase smart contracts, he was very much thinking about the management and the movement of digital assets. And then Ian Grigg, when he invented Ricardian contracts, he was thinking more about the legal side. So he was thinking, how can we template legal agreements and make them machine-readable and allow machines to enforce them? And so we do have some differing perspectives. Talking about Ethereum smart contracts is closer perhaps to what Nick Szabo was thinking about. They are very easy to use to, say, move Ether and to do computation. If you want to use them for legal things, then obviously there's an extra layer that you have to add to enforce that. Okay, so we had Bitcoin came in 2008, 2009, and some very ingenious ways were thought about to extend the way that Bitcoin works, to do some new things, particularly things like colored coins were used to do this, and a lot of ingenuity. But really, people were pushing the boundaries of what Bitcoin could do, and it was only in 2014 with Ethereum that we took really the next step forward, and we allowed general computation to be done on the blockchain. Now, back in 2014, when I first heard about Ethereum, and I heard that what in actual fact happens is that these smart contracts, these pieces of code, they run on every node on the Ethereum network at the same time, and they do exactly the same thing. They run exactly the same piece of code. And I found this rather confusing, and I was a little disappointed perhaps, and thought this is very wasteful, very inefficient. But if you think about it, it's not really about efficiency. What we're trying to do is to build up a consensus, to build up an agreement so that we can have trust in our system. And that's why we have to do exactly the same thing in the same place all around the node, all around the network. So if we take our usual actors when we talk about any crypto thing, Alice and Bob, you can imagine that Alice decides to write a smart contract, and she's going to deploy this on the network I've represented here by some little servers. So she sends a transaction out into the Ethereum network containing her smart contract, the piece of code that she wants to deploy. And that gets passed around all of the nodes on the network, so everybody then has their own copy of what Alice has written and can see what exactly it is. Now, Bob comes along, he wants to use this piece of code, so he can call a function. And the way he does this, he sends a transaction into the network, which calls a function on this contract. And again, because this transaction passes around the node, it is gossiped around the network. This happens on all the nodes at exactly the same time. So we have an initial starting point that everybody agrees on. So we have the initial state of the system that everybody understands and agrees. There's a call of this function, so Bob asks this system to do a certain thing. He runs a certain piece of code, and again, everybody has exactly the same piece of code. They run it at the same time, so they should end up with the same state at the end of this. So this means that we can have trust in our system. And this really brings us to the features of smart contracts. So Alice has sent out her contract, everybody gets a copy of that, so there is transparency about what it does. You can be sure that the piece of code that you're running does a certain thing. If you want to, you can inspect the code. It's not necessarily very easy for non-technical people to do this, but it is possible. So you can look at the code and you can know exactly what that code is going to do. At the moment, if you're using some apps on your phone, Facebook or whatever, you kind of trust them, but you don't know exactly what those things are doing unless you have the source code. And even if you have the source code, do you know that that's exactly what has been deployed? Do you know that somebody hasn't interfered with it, or it hasn't been updated in some way? With smart contracts, you do have that assurance. You can see exactly what is running when you send in your transaction. We have immutability. So the big selling point of the blockchain, immutability, we have immutability of the contracts here. So that piece of code that has been put on the blockchain, you know it is not going to change. So no hacker can go in and change it to make it do something malicious. It's just impossible. Now, there is a downside to this, of course, because the developer may want to change the code, but they can't. So obviously that contract is there, it's going to stay there. If you want to change your smart contracts, you have to do it in other ways. You have to switch to a different contract. So there are downsides in that way. Resilience, well, we're building this on a peer-to-peer network. It has no single point of failure, so you can be guaranteed that you're going to have 100% uptime of your network. And easy access, anybody who can start a client on the Ethereum blockchain, on the Ethereum network, or has a light client, they can easily access your application. There are plugins for browsers that will allow you to do this, so you don't have to have any special software otherwise. Okay, typical applications work in maybe this way. This is perhaps how a lot of people will do an ICO. They'll have a smart contract that is going to hold some Ether, and we'll maybe we'll give out some tokens in return, and perhaps link that to some underlying asset that they have digitized in some way. This is a very common pattern, and then the investor will get their tokens. But it's not all about computation. You also need other things as well. And so for that, there are other systems. A very common thing that you use with Ethereum is a system called IPFS, the Interplanetary File System, which allows you to store arbitrary amounts of data. Storage is also another one where you can do that. Or Swarm is the Ethereum equivalent. Messaging, we also have Whisper on Ethereum that allows you to securely send messages around. So these are the components really that complement the computational side of smart contracts. Recently, we had this being set up earlier in the year. So when Ethereum was originally set up, it was introduced as a general purpose blockchain, general purpose system. It was not particularly focused on any business domain. So the Enterprise Ethereum Alliance was brought about to try and bring some enterprise expertise and to give that advice to Ethereum and to try to help Ethereum to move into ways that will help the enterprise. And as you can see, you have some very large institutions, banks, etc., who are involved with this. But there are drawbacks. So when you're developing smart contracts, when you're using them on the Ethereum network, you need to be aware of this. One of them, this is going to be particularly important, I believe, is to do with privacy. So one of the big advantages of blockchain is the fact that you have transparency. Everybody can see what has been happening. You can see all of the transactions, so you can verify that what's happening is valid. But what happens if you have data that you don't want everybody to see? So this is going to be a drawback, and we're seeing regulation going to be coming into this area with GDPR. So you're going to be people are going to be able to say, well, what information do you hold about me? About what personal data do you have? And if I want that personal data to be removed, I have the right of erasure to remove that. This is going to be a big problem on the blockchain. The typical way to get around this, if you're working with smart contracts, is to encrypt data before you put it onto the blockchain. And really, that's the only way that you can get around that. Any data, any transaction you send onto the blockchain, everybody can see that. And if it's stored in a smart contract, they'll be able to see that also. Another problem represented here by something that was mentioned a little bit earlier this morning is that we want our system to reach consensus. We want everybody on the network, every person running a smart contract to have exactly the same view of the system, to have exactly the same state. Now, if you had the situation where smart contracts could go out to get external data, say they wanted to get some data about the weather or some financial instrument, that could potentially produce a problem, because you could have some of these nodes would be able to go out and they could successfully get some data, but perhaps they would get it at different times. They might get a slightly different view. But also some nodes might have difficulty going out to get information. They may be behind a firewall or something like that. And as soon as this kind of thing happens, then you would get consensus failure. You would have nodes on the network that had a different view of the system. They would hold different data, the whole network would be split. So in Ethereum, you cannot have this situation. With smart contracts, they are not allowed to go out and get information for this reason. So when you're writing code for smart contracts, when you're developing them, you have to be aware of these restrictions. What you're doing is very much restricted. If you're used to developing in the traditional world, you're used to writing in high-level languages, fourth-generational languages, or whatever. When you're developing smart contracts, you have to get used to the fact that this is going to be very restricted. Your code is very much sandboxed, it's very much restricted in what it can do, just for this reason, that you want to make sure that it is completely deterministic and that everybody who is running your code gets exactly the same view of the system. Every bit that is contained within your smart contract has to be exactly the same everywhere that it is held. Of course, Ethereum isn't the only blockchain, and there are other people who develop projects to run smart contracts. I'm not going to talk about these. We're going to hear from Hyperledger very soon. We've heard about Tezos. They have interesting ideas to do with governance and trying to do self-governance. But obviously there's been recent embarrassing things for them around that. Lisk is also there for writing in JavaScript. When I talk to clients, we get a lot of people coming to me saying, we want a blockchain, we've got an idea. Obviously, there's a lot of hype about it at the moment, so I do try to work out whether they really do need a blockchain, and I've formulated some questions, some areas that I like to explore into a framework to work out if they really do need a blockchain. So these are some of the areas that I tend to look at if they want me to write a smart contract. So if these things are important to them, then perhaps this is going to be something that will be suitable for a blockchain. But it's not just a binary decision on all of this. You just suggest initial avenues so that people can explore. Certainly in the workshop we have later, I think perhaps these questions will be useful. But things like, is your system all about trust? That's a primary use case for blockchain. Transfer of value, smart contracts find this very easy. If you have Ether in a smart contract, it's very easy to transfer this between accounts. System availability is a great thing because as a developer of a smart contract, I can put out my smart contract and I can be sure that it's going to be available to everybody at no cost. It's a great for the business model because I develop my contract, I put it out onto the network, I pay a small amount in a transaction fee to deploy that, but for me that's the only cost I will ever see really, because once I've done that, the people who are using my system will be paying the transaction fees that maintain the network. If nobody uses my system, I don't have any costs, so I don't lose out. It's great from that point of view. Resistance for censorship and fraud are also good, obviously. Publicly available data, as I mentioned, there are two sides to this. So if it's important to you that people can see your data, that people can be aware and will need to build up trust in the data you have, this is a plus point, but perhaps that's not something you want. Often financial institutions don't want this, so maybe you will need to encrypt your data before you put it onto the blockchain. Again, I spoke a little bit about immutability. Obviously, if you want to audit, you want a great audit trail, you want to be sure that people can see that you had a piece of information at a certain time, then immutability is going to be a plus point for you. And the kind of availability that you maybe want multiple people to be able to write into your blockchain without having to know necessarily who they are. And anybody who can access your blockchain will be able to do that. Just quickly how I think the smart contracts are being used. We've heard from Electron, they're using it for energy. There's a lot of people using it for asset management at the moment. I was involved in some work with healthcare. The idea that you may want to get patient records onto blockchain, so to stop the fragmentation of data that we have at the moment, to reduce the number of silos, but also to allow people to own their own data and to have some say in who can access that data and what rights they have over that. InsurTech is another great use case. We have the B3I group who are building lots of insurance applications. Okay. Because this is an ICO fest as well, so obviously initial coin offerings are going to be on everybody's mind. And one of the reasons I think that these have really grown in the last year or so. It's just the ease that these can be done on the Ethereum blockchain. So a standard was introduced around tokens, the ERC20 standard, which really said, well, these are some functions that tokens should implement. So, and if your token implements these, well, then people who write software for wallets or who write software for exchanges, they will know that your token implements these. They will be able to interact with your token by employing, by calling these functions. It's an interoperability. It makes it much easier for people to use your tokens. So these are, this is really the basics of the ERC20 standard. Obviously, without the actual functionality in it, this is just the interface in effect. But it's ridiculously easy to write a cryptocurrency on Ethereum. This is perhaps the simplest that you could do it, just having one main function. But this really is all you need to implement your own cryptocurrency, to write your own token. And I think this simplicity, this ease with which you can write these things is one of the reasons that ICOs have really taken off recently, and so many people have got involved with them, with producing them. Okay, that's as much as I want to talk about initially. Obviously, I want you to be asking me questions. If you need to contact me with questions, I'm happy for you to do that. There are my contact details. But I haven't gone into much technical detail. But if you want to ask more technical questions, then please do so. Okay.
Hello, my question is, can we provide network privacy within the Ethereum platform?
No, so everything that goes out onto the Ethereum network is going to be seen by everybody who has a node on the network, if you're talking about the public network. But of course, if you can also use the Ethereum software to create private networks. So in fact, much of the work that I do is on private networks. So you can then restrict the people who are allowed to join your network in a number of ways at the protocol level, but also you can firewall off your network anyway as well. So you can do that and just restrict the people who are allowed to join your network, but if you're on the public Ethereum network, then no, anybody can join. Yeah.
In reality, does all these smart contracts, stay in each individual computer on the network, or it's distributed in a smarter way? Because the transaction amount will increase incredibly, so it's going to be even harder to process and keep.
Yeah, so this is exactly my reaction when I first heard about this. I was used to the idea that you would put out some task into a network and it would be distributed and split up amongst nodes. That's not the case. With Ethereum, each transaction that is put onto the network is processed by every node in that network. Yeah.
Okay.
So.
And what happens when someone just penetrates a node and disrupts the smart contract? Then the rest of the network resists that because there is a manipulation in the code?
Yeah, so
how it works?
So there's the consensus mechanism, which at the moment is proof of work. So you have a miner which has collected the transactions and put them into a block, and then that miner then sends them out and says, this is the definitive state of our system at this point, and all of the nodes then use that. If one node decides to do something different, well, they will just be ignored really, because they're not passing out the definitive state of the system. It's just the miner who will do that. Obviously, if a miner does something malicious, that is a different case. You use proof of work to ensure that the mining is effectively passed around at random. So if one miner did something malicious, and really all they can do is to drop transactions. They can't corrupt transactions in any way, because you've got cryptography to stop that happening. But they can drop transactions or put extra transactions in. But if they did that, then the next miner to come along, who again is chosen effectively at random, so you'd assume there's no collusion, the next miner might drop that block and mine on the block previous to one that they'd passed out. And so the block that had been produced by this miner who was doing something malicious would also get dropped. There would be a temporary fork, but that fork would just die out.
But what if it was my block that another miner added something, so all my previous assets will be worthless.
So the only way that you could eventually do this and get all of these blocks to be done maliciously is if you had enough computing power to take over more than half the network, which is just economically infeasible.
Not possible. Not
Yeah.
possible. Okay, thank you.
Efendim var bak.
Hello.
Hi.
So the risk of consensus failure and that the smart contracts are not able to get out and pull that data is actually quite limiting and constraining.
Yes.
What is your vision about this? Are there any opportunities or ideas which are addressing this issue?
Indeed. So this is a great restriction. One of the ways around this, briefly mentioned this morning, is to use oracles. So you go out to an external source, to maybe a company, so a company like Oracle Eyes, who have been doing this for a long time, really the main person, the main company involved in this, and they will agree to provide you with data. So you say to them, tell me the weather in Istanbul every hour, and they will send a transaction into the network for you every hour to say the weather is this. And because that transaction is passed around the network, everybody will see exactly the same piece of data, and so there'll be no consensus failure. But yes, you're right. It is a great restriction. But the way around it is to use oracles. Yep. Hi.
I'd like to ask about what will happen when the price of Ethereum will increase. Because when the price of Ethereum increases at the same time, is it going to be feasible to use the Ethereum-based smart contracts?
Mm-hmm. So there is something that I haven't mentioned called gas, which is how the price of the transaction is worked out. So effectively, there is an extra layer here. So you pay for your transactions with Ether, but there is an extra exchange rate in the middle called the gas price. So as the price of Ether rises, you can reduce this gas price, which means that the cost of the transaction shouldn't change too much over time. Obviously, if it became too expensive for people to do transactions, people would stop using the system, so the miners would then be forced to reduce the price of gas, so because they would be getting no transactions, it wouldn't be making sense for them to keep mining. So there is a dynamic equilibrium involved there, yeah.
Hi. We know that blockchain is immutable, so smart contracts are also immutable.
Yep.
And in reality, due to business requirement changes or regulation changes, we need to update our code, our programs, according to the new changes.
Yes.
But in smart contract world, we cannot. Are there any mechanism that enables us to overcome this issue, or how do we solve this problem?
Okay, so yeah, very good question. So the way this is solved is that you actually have a proxy contract. So rather than calling a contract directly, you have a contract that you call is in the middle, which then can point to different versions of the contract that you really want to call. So as your old contract is, you want to get rid of it because it's got a bug in it or because there's some regulatory change or whatever, you introduce a new contract, and then the proxy contract that's in there in the middle will point to your new contract instead of the old one. So that's how you get around it, yeah.
Maybe last question from this gentleman.
What's your opinion about private and permission blockchains, and do you think these blockchains can utilize all of the good side of public Ethereum blockchain?
Mm-hmm. So I have found that a lot of my work actually is working on private blockchains, because at the moment it seems the clients are perhaps more comfortable with that. But there are some very good advantages for the public network. And I see someone once commented that private networks, you will often find that people use those for making cost savings and making things more efficient. But the real changes, the real revolutions that are going to happen, the changes to society, will happen from contracts that are on the public network. Another great thing from the public network is that you have on Ethereum, you have a fantastic developer community who are there solving problems, and you get the benefit of their experience. And also they can introduce libraries. So there are common pieces of code that are useful to use that will be there on the public network that obviously if you've got your private network, you don't necessarily have those. So yeah, there are some great advantages. Yeah, thank you.
Thank you, Laurence. Thank you.
Pleasure.
So we're done.